been listening about ENSO for more than 1 hour, so I will brief here. So generally, in the tropical Pacific, warm ancestors can be found in the west and relatively cold ancestors in the east. Also, the convection which follows the warm ancestry is placed over the west. During heavier conditions, when the trade winds are weakening, it disturbs this upheading in the cold region and expands the warm ancestry here. Similarly, the convective zone is shifted eastward. Then, these changes in the convection influence the global circulation and state connection pattern. So, as you can see from this figure, much of the impact is located in the tropics. However, the issue is, it doesn't matter we are from tropics or not. It can influence, the El Niño can influence us either through modulations in the weather directly or indirectly through social economic impacts. And then the motivation for the present study is comes from a recent study published in MCC. Here, but the authors, they use idealized CO2 ensemble experiment, and then they show the discharges of the ITC. The point here is, by showing the changes in the precipitation between ramp up and ramp down, they suggest in the ramp down phase, the global climate may experience anomalous conditions similar to extreme El Niño. However, their study does not focus on the extreme El Niño. Therefore, we are interested to further examine this point. Actually, the increase in frequency of extreme El Niño under global warming is already known. For example, Professor Sai and his team, they showed that under global warming, the occurrences will be doubled. The important point is, the mechanism is the present day climate and future climate quite similar. However, instead of using the traditional definition, they use precipitation to define this extreme El Niño. Therefore, here onward, we are focused on convective extreme El Niño. As the reason for this enhanced frequency, what they suggest here is the warming rate in this EEP region is faster. So, if we have a warmer background state, with a weaker SST perturbation can easily strengthen this convection, hence it can lead to more CE events. And also, still there are no studies which examine these changes in the convective extreme El Niño in the CO2 removal scenario. So that is an important scientific question. Therefore, we wanted to find out answers for this one. First, how CE will change in the CO2 removal scenario, and then what are the physical processes, impact on its frequency and intensity, and then finally, what will be the impacts. So we use fully coupled CSM1 example experiment for our present study, and in addition, we use 5 models from CDR field. So actually, this model experiment is quite similar to that used in Fugato 2020. And then here, to define the convective El Niño, we use the same definition suggested by Professor Sai, but it says the boreal winter total rainfall larger than the threshold value 5 mm per day in the Nino 3 region. Actually, the validity of this definition has been discussed in a series of papers. For example, here I show that the definition clearly identifies the recent 3 extreme El Niño events. First, we examine the changes in the frequency. So, here, this shows the relationship between the meridional SST gradient and Nino 3 rainfall. In agreement to the previous findings, we can clearly see this nonlinear relationship, and that relationship is maintained over the other warming periods. And also, in agreement with the previous findings, the occurrences in the ramp up period is doubled from the present day climate. Interesting point is, during CO2 reduction phase, the number of occurrences explosively increases up to 34%, which is 4 times compared to the PD, and then 2 times compared to the ramp up phase. In addition, during the restoring period, still the occurrences are large, though the CO2 level is returned back to the present day climate. Therefore, this seek an understanding why these occurrences are increasing, and then what are the causing factors and how the impact will change. To further understand this one, first we examine the evolution of El Niño frequency and then the intensity. So you can clearly see from this graph, the evolution of frequency and intensity is asymmetric to the symmetric CO2 posing. Showing that one, we can see the frequency and intensity is much larger in the ramp down phase compared to that of ramp up. And also, in year 2 to 80, when the CO2 level is returned back to the PD climate, still the number of occurrences and the intensity is much larger. So this suggests some kind of a strong hysteresis behavior. Even we examine for another extended time period in the restoring, still we cannot see the frequency and intensity is returning to the PD level. So this is suggesting some kind of irreversibility. To understand this one, first we examine the evolution of NINO3 SST and precipitation. So you can clearly see the response of this evolution of SST and precipitation is also asymmetric. And the point here is, if we examine the SST, it shows slower cooling. So it means it can maintain a warmer background state in the ramp down phase. So that is supportive. In addition, the evolution of the precipitation. So it shows the mean state is high in the ramp down period. So this enhance in the mean precipitation in this region is already identified because of the latitudinal shift of the IDC. So what we can say here is, if you have a strong mean state, so then it is easy to exceed the threshold of 5 mm per day. So this play a role. However, besides this, we cannot explain the changes in the frequency and intensity solely depending on the evolution of the mean precipitation. The reason here is, if you examine this evolution of the mean precipitation and the intensity, they show some differences. Then we thought about the changes in the sensitivity. Actually, the study published in Nature, they highlight this point. So here, they show the nonlinear relationship of SST and precipitation for the tropical band. And here what you can see, this is the present day climate. This relationship will be shifted to the warmer climate, and still the period will be almost similar. However, the slope is becoming steeper, which is suggesting in a warming climate, the response of the precipitation will be enhanced. And then here, this star mark is presenting the position of the NINO3 region. So you can see it is little bit shifted. And then we examine this relationship in our experiment. So in agreement to the previous findings, we can see this nonlinear relationship in the present day climate, and then that is maintained throughout the warming period. In the ramp up phase, you can see that the relationship becomes stronger as suggested by previous findings. However, the important point is, in this ramp down period, the relationship looks much stronger. And even we come to the restoring period, still the relationship is weakening, but is still higher than the present day climate. So we can here identify that precipitation sensitivity is playing a role. To further show this one, here we display the extreme El Niño composite for the ramp up and ramp down. To avoid the impact of the magnitude, here we select cases in between 1 degree to 2 degrees Celsius. So we can clearly see in this region, the precipitation response is much larger. So by showing this one, we suggest that we have seen the change in the frequency and intensity in the CO2 reduction period, and then that may be related to the associated with the latitudinal shift of the IDC set, which modulates the mean precipitation, and as well as this in enhancing the precipitation response. So you may wonder why we want to highlight this one. Generally in the EEP, that is the climatological subsidence region. So weak SST anomalies cannot overcome that subsidence. But however, if the mean state is warmer, so then weaker SST anomaly perturbation can trigger this precipitation. So that is related to SST. And also, in here, if you take this region from 2 to 8 millimeters, the linear part, we can divide this one into two regions. So in the first phase, it is rapid increasing, and in the second phase, increasing but slowly. So still this NINO3 region is in the rapid increasing phase. So we can experience this one. Then we wanted to find out what are the associated impacts. To understand this one, first we examine the teleconnection pattern. So here it is a composite of CE in present day climate and ramp down period. We cannot see significant difference between these two patterns. In addition, first next we examine the contribution to the mean state considering the frequency and intensity. So here you can see during the ramp down phase this signal is much stronger. By showing this one, here we can say the teleconnection pattern of CE is almost the same, but more frequent and intensive CE events contribute more to the mean climate state, and then the impact will be larger in the regions where CE impact is already evident. To further clearly show this one here, we display the difference of contribution to the mean state between the ramp down and present day climate. So you can really see some regions like tropical Africa and then extratropical northern and southern America. So they may experience enhanced weather conditions. The regions like this tropical South America, northwestern Australia, Asia, they can experience enhanced dry conditions. Also, we check the changes in the extreme precipitation rates. So, in agreement with our findings in this contribution to the mean state change, the result is quite consistent. Then, we summarize this study like this. So, we have investigated the future change in frequency and intensity of CE, and then we show that CE will be more frequent and intense during the CO2 removal phase, and that is associated with the southward shift of the ITCZ, and then enhanced nonlinear precipitation response to given SST in the region. Also, we have observed some irreversibility that may due to the different adjustment time scale of the associated climate components. In addition, future changes of the CE will contribute to the mean state change in the regional climate due to its intrinsic nonlinear characteristics. Because there are convective extreme El Niño, but it is not possible to find convective extreme La Niña. And then the projected large increase of sea events, the more frequent occurrences of potential devastating weather events can be anticipated in future, even though the CO2 emissions are reduced and even negative. So here are some key references, and we kindly acknowledge all the scientists participated in the data production and all the funding sources, and thank you.
Okay, we have time for the question or comment. Okay, Mr. Kam.
Slide 7, we show the slide. The E intensity seems to respond really quick. So E intensity responds really quickly because the CO2 really increased that much, but the 2000s, you can see the green line increased a lot. Do you expect why that happened? Like it seems the timing is not really well matched as a CO2 response.
So you are focusing on this one, right?
Yeah.
So to show this one, actually we selected we focus on the maximum intensity case. So here we have 28 samples and 31 year window. So in that
This question is why the intensity is so much delayed compared to can you explain?
in this region or this region?
The first, yeah, the green line. So it's a ramp down period.
Maybe
This one.
Yeah.
Okay. So here the case is that we already shown this one because the changes in the sensitivity.
next one is the dust comment. And then we show the precipitation change over the land. But I think that because of the ensemble mean, so the magnitude itself is really small. So that like 0.5 or 0.7 millimeter per day change in terms of the mean state is, I don't know, the clear linkage with the extreme weather, like the flood. Because the last conclusion is to try to link with the extreme weather, right? Yeah, so that is not good. If you have any comment,
Here actually we wanted to suggest is that during the ramp-up phase, there will be more occurrences and also the intensity will be large. So if you have strong intensity and strong cases, so the contribution can be large compared to the PD cycle. So here the values are little bit bigger because we take the difference between this contribution to the mean state change. Actually, here we take the cumulative summation of total cases in that period and then divide by average over total years. So that's why values become smaller.
But you already explained it. You already analyzed the extreme precipitation. Right? Since he asked them.
In this. And also I forgot to tell you, in here is the unit is the number of days per 31 year window.
Okay, any other question?